Okay, hello. Today I'm going to go over quiz 8 about estimation chapter. So we learned basic like point estimator and interval estimator. So but actually what you're going to do here is pretty much like mechanical calculations. But we learned basic derivations and the criteria behind it. So let's start. So the first question, find the value of z from the standard normal distribution that contains 70% between plus minus z, right? So we are going to round at the second decimal place. So this will be used in this chapter and the following chapters too. So what we want is this one. Lowercase z plus minus lowercase z contains uppercase z, which is like random normal distribution. So 70%. 70% is in the middle. And that means what you need to think about is due to the symmetry of standard normal distribution, when there is 70% in between plus minus z, the other 30% is evenly split between below minus z and above plus z. So lower tail, upper tail have the same probability. And then what we want is, in the end, we want to convert that probability as a cumulative probability for z. That is what we have done in the earlier chapters. And then, because below z, the cumulative probability includes these two cases, right? Above z is 15%, but below lowercase z is 15 plus 70%, so it will be 85. That means if you move to normal Excel, let me increase this. So then you may use this formula, standard normal distribution inverse, and we are going to put 85%. Then you will get a number. So in case you don't have rounding, then you may round using this button. So if you round at the second decimal place, it will be 0.04, right? So then, I may recommend, also, you may automate what you are doing. For example, so if your confidence level is, say, 70%, so if you put 70% here, then what you can do here is first take half of that. And then subtract from 1. Like it is. Excuse me, the other way. Subtract from 1 this guy. And take half. And again, what's this? It's right, and then subtract from 1 again. This is the cumulative probability. This is cumulative probability for z value, right? This is what we are doing. If you make it as a worksheet, then we are going to do it this way, right? And then finally, you are going to use this value as cumulative probability, so put that into the formula. That is what we are doing here, right? So remember, these are the steps we are doing, and the idea behind it is this one. So imagine the bell curve, and probabilities are 70% in between, but each tail has 15%. Okay, so get used to it. Second question. Suppose that you own a coffee shop. We want to estimate the population mean of the daily sales. A sample of past 5 days of sales data provided the following information. So it is just raw data. You observe 5 numbers, 94, 100, 91, 94, 91. You are going to use the sample average as a point estimator for the population mean. You also want to measure the accuracy of your estimator and use the standard error as the measure of the accuracy, which is common. What is the standard error of your point estimator? When you calculate a variance or a standard deviation, use the sample version formula. Okay? Right? So first, just to review what we have learned, we are going to, when you estimate the population mean, we know that the sample average, sample mean is the best estimator, best point estimator. That's one thing. And standard error is another name for the standard deviation when when you do estimation, right? So then let me think about the way we can solve this problem. So first, let's think about x. Define the random variable x as the number of coffees sold on a day in your coffee shop. And the parameter you want to estimate when you do the estimation, the parameter of interest is this population mean, which is the expected value of the random variable x. Okay, it is unknown, so this is known only when you have infinite number of observations. So it is unknown. And then the best point estimator for the population mean is the sample mean. You know how to calculate that. So because you have 5 observations, you can calculate its average by this way. So add sum 5 numbers and divide by 5. That is the sample mean, which will be the best point estimator. But what we want is the standard error. Standard error of an estimator is its standard deviation. So just standard deviation of an estimator is called the standard error, right? Basically, a special name in estimation framework. Anyhow, so we are calculating this guy, standard deviation of sample average, because this is the estimator, which is random, right? And how to calculate that? We learned standard deviation of the sample average is the standard deviation of a single outcome divided by square root of the sample size. What we learned from chapter 7, right? And then it only remains to calculate the numerator. What is the standard deviation of these numbers? That's it. By the way, you may do it by hand, but I would recommend just use this one. Like say, I will copy the numbers 94, 100, 91, 94, 91. And then we can calculate its standard deviation, but standard deviation dot s, because the question tells you to use the sample version. So use this formula stdev dot s, and here choose these numbers and enter. Then you get standard deviation of 3.64, 3.674 something, right? So also you need, by the way, this is only the numerator. I just calculated this part, standard deviation of single outcomes, right? But what you want is the whole thing. So you have to divide it by, you need to divide this number by square root of 5. The sample size is 5, so you have to do it this way. Okay? By the way, it may be confusing. So when you do when you calculate the standard deviation, because we are using the sample variance formula, so the denominator is n-1 there. When you calculate the standard deviation by choosing .s option, so you are using n-1 in the denominator, but we are taking denominator again. We are dividing by square root of n again, but in this case, it's always n. So it is from, these two denominators are from different things. So the first denominator, square root n-1, is from estimation of standard deviation, but the second one is from the sampling distribution theory. So they are different But if you just memorize this one, if you understand this formula, it is clear. It has to be only n, not n minus 1. So potential confusion, but so. But if you're confused, that means you study hard, so you know something. Okay, anyhow, be careful. And this is how you calculate the standard error. Okay, so this sampling distribution formula is used. Next one. A random sample of 100 U Albany graduates had an average hourly income of $50 with a standard deviation of $12. Find the margin of error for the 95% confidence interval for the mean hourly wage of U Albany grads. So we only need margin of error, and it is from here. It is pretty simple. So what we learned is when we estimate the population mean and using an interval estimator, you are going to calculate the margin of error using this formula. So you only need 3 numbers. But actually, standard deviation is given 12, sample size is given 100, so you only need to do this part, which is same as the first question. So we denote z alpha, we use z alpha over 2 because it contains 1 minus alpha plus minus lowercase z alpha over 2 contains 1 minus alpha, which is confidence interval. So going back to Excel using the worksheet we made in an earlier question. So I'm going to put, say, 95%. Then you are going to get another number. So round. You will get 1.96. This is the number, approximate number that I used in lecture note, and you can just copy the number from the lecture note. As long as the confidence level is 95%, okay? But I wanted to show you this is how we can do it in a complete way, right? This is the complete work, but in the end, we are going to get this number. This number goes to this part, right? Okay, then it's pretty simple, right? So 1.96 is the lowercase z alpha over 2, and as I said, plug in standard deviation, sample size. That is the margin of error. Simple. So it took like an hour to derive this formula, but in the end, using the formula is pretty simple. And all right, okay. Another question. By the way, we are going to repeat this formula like many times in this quiz. That's how you learn the formula, okay? Next question. A survey of 100 businesses revealed that the mean after-tax profit was $80,000 and the standard deviation was $15,000. Determine the 99% confidence interval estimate of the mean after-tax profit, right? So same thing. Same thing, we are going to use random variable x for the after-tax profit for a randomly chosen business, right? And the parameter is the mean, population mean, which is unknown unless you observe infinite number of businesses. And then the confidence interval, because we are estimating the population mean, we may use this formula. So confidence interval looks like this. And again, we only need 4 numbers. X bar, given here, 80,000. Z alpha over 2, which we need to do a little calculation. Or you can take from the like textbook, lecture note. And standard deviation, given here. Sample size, given here. So sample size 100, standard deviation 15,000, average 80,000. So you only need lowercase z for 99% confidence level. We know it is approximately 2.58, or again, if you put 99% here, then it will give you 2.58. Let me put it as alpha, right? So if you make a worksheet like this, you may take this number. It doesn't matter which confidence level you use. In the end, you are going to get an approximate number. Good. So pretty straightforward. Plug those four numbers into the formula and calculate that. It'll be your confidence interval. So because we have plus and minus, so plus, if you put plus, you are going to get upper limit, and minus will give you a lower limit. So straightforward. Next question, another similar question. A random sample of 100 households was selected as part of a study on electricity usage, and the number of kilowatt hours used last quarter was recorded for each household in the sample. The average usage was found to be like 377.1 kilowatt hour, and the standard deviation of the usage was 25. Find the upper confidence limit of the 95% confidence interval for the mean usage in the last quarter. Same structure, right? Identical structure as what we have done. So we are going to use this form. Now we only need plus because we are only calculating upper limit. Upper limit given by plus, and so I give you sample average, standard deviation, sample size, and z alpha over 2. Again, for 95%, you get 1.96. 1.96, plug that in. That's how you calculate that. Okay, so next question. another question, but it is a little more complicated. So it is desired to estimate the mean tensile strength for roof hangers. It is known that the standard deviation of measurements of tensile strength is 0.25, and units are Newton per square meter. I don't know. Anyhow, so point is standard deviation is 0.25. As it is very important for safety, so something should be hung to the roof. So it is important for safety. So we need 99% confidence interval. We would like to keep the confidence level high. Confidence interval needs to have a margin of error, margin smaller than 0.04. So margin of error should be also small, like because it is related to safety. You have to be very, very conservative. Then, what is the minimum required sample size for this estimation? Okay. Remember, it is about the sample size. You need to solve for the sample size, not interval or margin. Okay. So we start from the margin of error formula. We have margin of error for a 99% confidence level this way. And we already used like 2.58 earlier for 99%. And standard deviation is given. We know the standard deviation, but we don't know the mean. Somehow, yeah. Standard deviation is 0.25. But what is also unknown is the sample size. Sample size is our choice in this case, right? And we would like this margin of error. This is margin of error. We want to make it smaller than 0.04. Right? Smaller, by the way, remember, smaller margin implies more informative confidence interval, right? So the smaller the better. Anyhow, inequality goes like this, and rearrange, move square root n to the other side, and divide by 0.04 both sides, and then you get, and then square to remove square root on n, then you get this. It is easy to calculate. Calculate this and find the smallest integer that satisfies this inequality. That is the minimum required sample size. Okay, I believe you can do this, right? It should be straightforward to calculate this inequality. Okay, the next one, the last one. Not the last one, sorry. It is last question, that's right. One is interested in the percentage of doctors who recommend aspirin rather than other painkillers for their patients with headaches. A random sample of 120 doctors results in 12 who indicate that they recommend aspirin. So among 120, only 12 doctors recommend aspirin, right, for headache. Determine the 99% confidence interval for the population of doctors who recommend aspirin, right? And find the nearest answer. I gave you some approximations in case, because it is, you need to choose one of the options. Anyhow, so what is new here is its binary structure. We have to think about the underlying variable as a binary distribution, right? So I will denote x equals to 1 if a randomly chosen doctor recommends aspirin for headache, and 0 if not. So success is if you happen to meet a doctor who recommends aspirin, right? That is success. And because it is a binary random variable, we also know that the p probability of success equals the mean. So our estimation of the proportion of doctors can be converted into an estimation of the mean, right? Mathematically equivalent. Okay, and standard deviation of the binary random variable takes this form. So inside the square root is the variance for binary. And in our sample, the only information about the data is like this. 120 doctor, among 120, only 12 are success, right? So the percentage of success in our data is 10%, right? 12 out of 120. So 10% is the sample average, right? That is percentage, but also that is the sample average. And then the standard deviation we can calculate from the sample becomes 0.3 because p is 0.1 in sample. So 0.1 times 0.9 is 0.3. Square root, if you take radical, 0.3 is the standard deviation. So only these two. Sample size is 120. And from these two numbers, we can calculate the sample average and the sample standard deviation. So calculate the confidence interval. It will be straightforward. Again, the confidence level is 99%. So you use the same lowercase z value, that is 2.58, then it should be straightforward. Okay, so as you see in this chapter is really, really important and very useful. It is about estimation. But the results, what you get is, what the takeaway is, it is really simple. The formula and the margin of error, as long as you understand that, calculating them is pretty simple. So, but I still want you to understand the underlying theory behind it, because when you make the model more complicated, then you may need to change the formula. So then what you need is the intuition of the behind it, the intuition about the sampling distribution and where the formula is coming from. Okay, thank you for watching. See you later.